Hi everyone, I'm Yukit. I'm a query engine engineer in CnosDB. Welcome to join our webinar. Please join our Discord channel as well. You should be able to see our link on the screen. The new course we are studying over the next few sessions will focus on stream processing. It will be divided into 4 parts. The first part will cover some introductory concepts, basic concept, and how stream processing is applied in time series scenarios. The second part will focus on how to implement stream processing in CnosDB. This will include some technical research we have done, as well as how to select these technical solutions. The third part will be about our implementation of stream processing in CnosDB, including which solutions we used to handle computations for time series data. The fourth part will walk through the code and give everyone hands-on experience with how stream processing is used in CnosDB. Of course, our stream processing functionality has already been released in the open source version, so anyone who wants to try it out can do so. All right, let's get into our topic today. In this first part, we'll cover what is stream processing. Of course, this is just the introductory. Some of you may already be quite familiar with the topic. Well, it doesn't hurt to review it again. What is the difference between batch processing and stream processing? Key concept in stream processing. What additional areas it needs to handle compared to batch processing? How does stream processing combine with time series data and is applied in time series scenarios? Finally, we will talk about the main technical challenges of stream processing and the main use cases. Let's start with what is stream processing. I hope everyone will think through with me as we go through this. I mean, on your mind, does what I present meet your expectation? First, what exactly is stream processing? Why is stream processing so important? What benefit does it offer? What are some challenges with stream processing? First, what is stream processing? Literally speaking, it processes a stream of data. It's a continuous, unbounded flow of data continuously arriving from various data sources. Why is it so important? Because it has a lot of great uses. Stream processing has been around for decades already. There are many open source frameworks widely used online, and many commercial applications as well. With those questions in mind, let's dig in. First, what exactly is stream processing? It is a data processing technology and paradigm. It performs fast, real-time analysis of continuous unbounded data streams. This includes filtering, transforming, or enhancing data across time, what we call differencing or interpolation in the time series context. After processing the data, we send it downstream. This downstream can take many forms: application programs, storage for the processed data, other processing engines, analytics engines like OLAP. A key point in this concept is the continuous data stream. This is one of the key features where the data stream processing has to handle. It is continuous and uninterrupted. Another key point is the fast, real-time analysis. Because the data is arriving in continuously, we need to process and respond to it in a timely manner. This differs from batch processing. In fact, stream processing is used quite widely in real life, with data coming from many different domains, including trading data, stock information, new user registration on website, industry equipment, sensors, remote sensing data, and more. The core idea of this stream processing already exists, as mentioned earlier, for many years. Nowadays, there are also many types of open source software cloud services, which should be familiar to everyone, since like Flink, Spark, streaming are widely used. Alright, after discussing this stream processing, let's now take a look at some differences between batch processing and stream processing. First, we need to look at the first law, which is the scale of data processing for batch processing and stream processing. Batch processing mainly deals with large chunks of data. Its data is typically in large chunks. On the other hand, stream processing deals with what we call micro batch which means it processes a very small amount of data at once. However, this data arrives continuously, and this is the biggest difference between them. This difference primarily leads to variations in their architectures and focus areas. In essence, batch processing has a delayed response, and its response time can be several minutes or even several hours, depending on the circumstances. In contrast, stream processing is different. It requires a quick response, meaning it expects you to process the data as soon as it arrives and provide result immediately. So generally speaking, the delay in stream processing is typically at the second or millisecond level for some operations on this data, like batch processing. Batch processing is mainly used in the OLAP domain, where it involves complex data analysis operations. Hence, its analysis operations are particularly intricate. This is because of the data volume and the complexity of the analysis operations, which results in higher response times. As mentioned earlier, in the realm of stream processing, it mainly performs simple aggregation operations or modifications, along with some statistic metrics on time windows. This is primarily reflected in stream processing, especially in the context of time windows, where it mainly works within a time window to perform some downsampling operations. For example, it might calculate minimum values, and there are some advanced operations as well, which I won't go into details here. This is just to highlight the difference. Another key difference is the characteristic of the data they handle. Batch processing mainly deals with bounded data, meaning it processes a batch at a time, and it doesn't continuously process data. Stream processing deals with data that arrives continuously and doesn't stop unless you stop the business processes. So, this point mentioned above are the main differences between them, and I believe this gives you a relatively simple understanding. Next, let's take a look at some basic concepts in stream processing. One of these key points is the data stream, which we mentioned briefly earlier but didn't emphasize. Here, we'll focus on the data stream. A data stream is primarily a series of continuous data, and these data points are ordered in time. For example, they arrive continuously as time progresses. However, within stream processing, time is divided into several categories. This includes the time when a record is triggered, the time when the record is generated, event time, the time when the record is ingested into our processing engine, and the time when the processing engine actually handles the data. This different type result in different behaviors for the stream processing engine. Of course, as we mentioned earlier, data arrives with the passage of time. However, due to the network issues or device failures, data delays or out-of-order data may occur, This is one of the challenges that stream processing needs to address. Now, let's look at the concept of time windows. Time windows are present in batch processing as well, but they are more widely used in stream processing. There are various types of windows, but we will focus on time windows here because they are quite typical. A time window is essentially a fixed size subset of the data stream. However, time window can also be dynamic, based on factors like the number of records or other criteria. The common types of time windows include sliding windows, tumbling windows, and others like session windows and state windows. Now, let's move on to parallel processing. Stream processing often deals with a significant amount of data because processing engines may need to handle data from numerous sources. For instance, in industrial settings, the number of sensors or equipment is substantial. Therefore, stream processing aims to maximize performance to meet the demand for real-time responses. Parallel processing techniques are crucial in stream processing. These techniques have been around for decades and are similar to those used in batch processing, involving partitioning and sharding data. Next, we have state management, which is a significant concept in stream computing and processing. Stream processing deals with continuous data arrivals and often involves window calculations. These windows, like a 5-minute window, dictate that the processing must span at least that duration. Additionally, other factors such as older data further complicate the situation. Therefore, there is a need for state management to save and aggregate data, ensuring resilience against failures and the ability to recover and continue processing. Another important concept in stream processing is processing semantics. This concept differs from batch processing and encompasses several options. Exactly once, each record is processed exactly once by the stream processing system. Achieving this level of precision may come with a cost. At least once, each record is processed at least once, but it may be processed multiple times. This approach is often selected based on a specific business scenario and requirement, and most ones guarantees that each record is processed at most once, but it may be dropped if an error occurs. This approach offers better performance compared to exactly once. The choice of processing semantics depends on the business need, downstream processing, and data storage considerations. In conclusion, we have covered some fundamental concepts of stream processing. I hope this provides you with a basic understanding of stream processing. Now, let's discuss the relationship between stream processing and time series data. Before delving into this, let's first examine the characteristic of time series data to see if it's suitable for processing using stream processing technology. First, time series data is type of data based on a time log. It often involves time sequences and timestamps. In other words, time series data include data points with associated timestamps. Within the context of stream processing, each data point can be thought of as an event representing when a record was generated. Stream processing data typically consists of recent measuring records, such as those from monitoring data in environment, like data centers. These metrics may include CPU usage, memory utilization, disk usage, and various other indicators. These metrics are regularly collected. Additionally, there are sporadic event records that are not collected on a regular schedule. They may be triggered by specific conditions. Time series data is often characterized by significant volume. This is because over time, data accumulated continuously, and there are often multiple data sources, such as numerous monitoring devices. Dealing with such large volumes of data present a challenge for stream processing. Stream processing demands high throughput and is time sensitive. This is because it primarily deals with time-based operation and is reliant on timely processing. Timeless is a crucial aspect of time stream processing. Thank you for watching the show, and you may join our Discord channel on the screen here below. We'll see you next time. Bye bye.